China has built a tunnel in a region with temperatures as low as minus 35 degrees Celsius. This is the country's first underwater rail tunnel.
The alarms were silent. The pressure gauges were holding steady. But 78 meters below the surface of the ocean, the crew knew they were walking on a knife's edge. One hairline fracture in the concrete, one loose bolt, and the entire ocean would come rushing in with the force of a bomb. This isn't a hypothetical scenario. This is the daily reality inside the most dangerous construction site on Earth. While the world was distracted, a team of engineers attempted the impossible. They didn't just survive, they changed everything we thought we knew about the deep. The impossible descent. Beneath the crashing waves and soaring peaks, something is happening that defies logic. For years, the global engineering community looked at the chaotic geology of the Chinese coastline and agreed on one thing: it was a no-go zone. The rock was too fractured, the currents were too strong, the cost would be astronomical. American and European experts looked at the plans for the Gintang Undersea Tunnel and essentially said, good luck with that. They mocked the ambition. They predicted delays, budget blowouts, and catastrophic leaks. But here's the catch. They were looking at the problem through the lens of yesterday's technology. They didn't realize that the rules were about to be rewritten. Deep beneath the surface, China is quietly shattering the ceiling of what is possible. We are talking about tunnels bored 256 feet below the sea. We are talking about bridges floating higher than the Eiffel Tower. This isn't just construction. It is science fiction turned into hard concrete and steel. And when you look inside, you start to understand why the mockery has turned into a stunned silence. Let's talk about the Gintang Undersea Tunnel. This is the project that made everyone pause. It is being built to become the longest and deepest tunnel specifically designed for high-speed trains. We are looking at a total length of roughly 10 miles, but the mind-bending part is that nearly 7 miles of that run continuously under the sea floor. Now pause for a second and think about the weight of water. At its deepest point, this tunnel sits a staggering 256 feet below sea level. That is like stacking a 26-story building upside down beneath the surface of the water. The pressure down there is immense. Every single square foot of the tunnel surface faces crushing atmospheric pressure. It is an environment that pushes materials to their absolute breaking point. A single structural failure, a single crack in the seal, and it is game over. The water would not just leak in, it would jet in with enough force to cut through bone. So why take this risk? Why build it? The answer is connection. This tunnel is the crucial beating heart of a larger project, the Ningbo-Zhoushan Railway. Its mission is to link the major port city of Ningbo with the Zhoushan Archipelago, a group of hundreds of islands. For the people living on those islands, this is a complete game changer. Right now, a trip that involves ferries and bridges can take an hour and a half. When this tunnel opens, that same journey will be slashed to a mere 30 minutes by high-speed rail. It will transform a slow, disconnected commute into a quick, easy trip. But building a tube for trains under that much water and rock is one of the most difficult challenges in modern history. The seabed here isn't a nice uniform layer of soft sand. Engineers have to navigate a geological nightmare. It is a complex mix of hard rock and soft soil, crisscrossed with faults and fractures. The single biggest, most terrifying threat is the water itself. To win this battle, engineers have deployed two monsters, two of the most advanced tunnel boring machines ever created. These are not simple drills. They are mobile factories, each the length of a large skyscraper laid on its side. Named Dinghai and Yongzhou, these colossal machines are currently chewing their way through the underworld. They don't just bore through rock, they simultaneously install the concrete segments that form the tunnel walls, creating a sealed tube behind them as they advance. This is a feat of pinpoint precision. These machines, starting from opposite ends, are navigating the deep, guided by lasers and satellites with the goal of meeting in the middle. The margin for error is measured in millimeters. Imagine trying to thread a needle from 2 miles away while underwater in the dark. That is what they are doing. The monumental work began in May of 2024. Progress is steady and hard-won. By October of the same year, the first of the giant boring machines, the Dinghai, had left the relative safety of the land and began its epic journey beneath the sea. The current goal is for the two machines to complete their boring and break through to each other by the end of 2026. The impact of this final connection will be profound. For the global economy, it links Zhoushan Port, one of the world's busiest, directly to the high-speed rail network. But for the engineers watching from the West, it is a wake-up call. It proves that with enough brute force and precision technology, you can go through obstacles that were once thought invincible. But if you think the ocean is the only thing they are conquering, you are wrong. Wait until you see what lies beneath the most dangerous river in the East, the River of Sorrow. If the ocean is a monster of pressure, the Yellow River is a monster of mud. Known historically as the River of Sorrow because of its deadly floods, the Yellow River is notorious for its unstable, shifting riverbed. You cannot just dig a hole here. The ground is soft, wet, and unpredictable. It is like trying to drill a tunnel through soup, but that didn't stop them. The Yellow River Undersea Highway Tunnel took a different approach entirely. Instead of carrying trains, it creates a massive highway passage. The bore of this tunnel stretches a colossal 57 feet in diameter. It is the world's largest diameter underwater shield tunnel. The sheer scale is almost incomprehensible. This incredible girth allowed engineers to implement an innovative single-tube double-decker design. Imagine a giant pipe. Inside that pipe, they built a road on top and a road on the bottom. It carries 3 lanes of traffic on an upper level and 3 more on a lower level. This creates a 6-lane superhighway moving through a single massive hole in the ground. But the truly fascinating part of this project is not just its size, it is the staggering pace. Famously known as China speed. The proof is in an almost unbelievable timeline. Construction on the tunnel began on September 1, 2024. From that start date, crews achieved the impossible. They completed the entire 1.2-mile-long underwater shield section in a mere 110 days. Let that sink in. 110 days. This represents an average boring rate of roughly 52 feet per day. In the world of underwater tunneling, 10 to 12 feet per day is considered good progress. They went 4 times faster. This unbelievable velocity was powered by a custom-engineered Titan named the Shan-He. This was not an ordinary machine. It was a technological marvel built specifically to conquer the soft, unstable soil of the Yellow River's bed. The Shan-He was a mechanical earth eater of immense power designed to operate under extreme pressure while simultaneously installing the concrete segments. It was the key that unlocked this record-breaking speed. While the underwater shielding was completed in that blistering period, the broader project continues. The tunnel is expected to achieve its full breakthrough by the end of 2025. The completion of this titanic tunnel will do more than just set a new world record. It will provide a vital, all-weather link for the city of Jinan. It stands as a powerful example of how modern engineering is solving urban problems not by going over or around obstacles, but by plowing straight through them. But here's the thing about speed. Usually when you go this fast, things break. People make mistakes, but in this case, the speed was the safety feature. By moving fast, they prevented the soft mud from collapsing around the machine. They outran the geology. However, moving mud is one thing. Dealing with ice is another. And up in the north, the challenge wasn't just the water, it was the cold that could shatter steel. Breaking the ice barrier. The Dalian Bay Undersea Tunnel is a beast of a different nature. It became the first cross-sea immersed tube tunnel built in cold northern China. Now, why does that matter? Because winter temperatures here plunge to -7 degrees Fahrenheit. Most people don't realize this, but cold is the enemy of concrete. Concrete needs to cure. It is a chemical reaction. If the water inside the mix freezes before the concrete sets, the whole structure becomes weak. It cracks. It crumbles. At -7 degrees, standard construction is impossible. The extreme cold threatened the entire project, but they needed this tunnel. The journey around the bay took an hour, clogging the city with traffic. They needed to cut that down to 5 minutes. So, how did engineers achieve this? They used a brilliant method known as the immersed tube technique. Instead of boring through the seabed with a massive machine like they did in the south, they built the tunnel in sections on land. Imagine crafting 18 gigantic hollow concrete boxes. Each one is the length of a large skyscraper laid on its side. In total, these sections stretched for over 1.8 miles under the sea. There were 13 straight elements, each a remarkable 590 feet long. Once these colossal elements were perfectly constructed, they were sealed up like giant submarines. Then they flooded the dry dock, floated these massive blocks out into the bay, and deliberately sank them into a pre-dug trench on the seafloor. It sounds simple, like playing with Lego blocks in a bathtub, but doing it with 60,000-ton blocks of concrete in freezing weather is a nightmare. Once settled, the water was pumped out and the sections were connected to form a continuous watertight roadway. But building the first cross-sea immersed tube tunnel in the cold north came with a unique set of brutal challenges. The project spanned 4 long winter seasons. The team had to develop special techniques to protect the massive tunnel sections. They couldn't use standard techniques. They had to invent new ones. Their most powerful weapon in this fight was the creation of what they hailed as the most advanced and highest capacity dry dock for an immersed tube prefabrication yard in all of Asia. This state-of-the-art facility was essentially a giant shielded outdoor factory. It allowed them to produce these massive tunnel sections with incredible precision and quality, all while protected from the worst of the freezing weather outside. The innovation didn't stop at the dry dock. To combat the cold, the team developed first-of-its-kind methods. They had to adapt their concrete mixtures. They used steam curing. They monitored the temperature of the concrete blocks with sensors buried deep inside the walls. Every step from mixing the concrete to sinking the elements required new protocols. This wasn't just construction. It was a series of engineering experiments happening in real time, all to ensure the final tunnel would be safe and last for generations. The total project cost roughly $1 billion. It commenced in May of 2019 and wrapped up in April 2023. The Dalian Bay Undersea Tunnel stands as more than just a convenient road. It proved that the advanced immersed tube tunneling technology honed on projects in warmer southern waters could be successfully deployed in the frigid north. It showcases a stunning ability to adapt to and overcome extreme environmental challenges. The steel sandwich. But if Dalian was about battling the cold, the Shenzhen-Zhongshan link was about battling traffic on a scale the U.S. hasn't seen since the Big Dig. This project is a 24-kilometer integrated highway system. It combines bridges, artificial islands, and a 3-mile underwater tunnel. Here is the problem. This link crosses 3 major shipping channels. These channels are the arteries of the global economy, used by over 4,500 large vessels daily. You cannot just build a bridge and block the ships. That would crash the economy. But you also cannot just build a tunnel the whole way because of the geology. The solution? Do both. But the transition is the tricky part. How do you go from a bridge 100 feet in the air to a tunnel 100 feet underwater? You build an island. 2 of them. Engineers constructed a massive island on the eastern side and another on the western side. These are not just piles of sand dumped in the water, they are sophisticated engineering platforms. They are the vital portals where the road disappears beneath the waves and emerges again on the other side. But the real star here is the tunnel. It is the world's first long-span immersed tube tunnel using a steel-concrete-steel composite structure. This is the steel sandwich. Think of it like this. Normal concrete tunnels can crack under pressure. Steel tunnels can rust or buckle, but if you take a layer of steel, pour concrete, and then put another layer of steel on top, you get something invincible. This design creates exceptional strength and durability for the extreme pressures of deep-sea conditions. Imagine building 32 gigantic watertight concrete boxes on land. Each one is as wide as an 8-lane highway. They floated these out and sank them with millimeter precision. The connection has to be perfect. If there is a gap the size of a human hair, the water pressure will find it. Above the water, the link features a stunning suspension bridge with a main span of over 5,000 feet. It arches over the main shipping channel to allow the largest container ships to pass unimpeded. The entire link cuts travel time across the Pearl River estuary from 2 hours to just 30 minutes. It effectively turns separate cities into one interconnected economic mega-region. But while tunnels are impressive, there is something primal about fear of heights. And what China is doing in the mountains makes these tunnels look like child's play. Walking above the abyss. To understand the full ambition, you have to look to the sky. You have to look at bridges that soar over some of the planet's most terrifying terrain. Welcome to the Longjiang Bridge. This monster stretches 6,500 feet across the Longjiang River Valley in Yunnan Province. Its deck is suspended nearly 1,000 feet above the ground. To put that in perspective, if you fell off this bridge, you would have time to think about your life before you hit the bottom. Building here meant confronting three simultaneous challenges: seismic activity, high winds, and steep, unstable slopes. This is a remote mountain location. Getting the materials there was a logistical nightmare. The site is seismically active. The ground shakes. Engineers had to design a bridge that could not only hold its own immense weight, but also withstand the powerful forces of an earthquake. On top of that, the high winds that whipped through the valley posed a constant threat. The wind wants to push and twist the bridge deck like a ribbon. This was a three-front war against gravity, earthquakes, and wind. The solutions were ingenious. The project began with two massive towers that anchor the entire structure. These are not simple pillars. They are designed with flexible foundations that allow them to sway and absorb the energy of a seismic event rather than crack. But the true marvel was the spinning of the main cables. These two giant bundles of steel wire are the backbone of the bridge. They were installed using aerial spinning. A helicopter carried a pilot rope across the gorge. Then they used that rope to pull stronger ropes, and finally the individual steel wires. They did this thousands of times high above the valley. The Longjiang Bridge creates a critical link in the expressway. It bypasses the slow, dangerous, winding mountain roads. But it is just a warm-up for the visual stunner that is the Gintang Bridge, the Cosmic Eye. Some bridges are built for function. This one was built for drama. The Gintang Bridge features a rare three-tower design. Its central pylon reaches 1,089 feet into the sky. Let's be clear about that number. That is taller than the Eiffel Tower, taller than the Chrysler Building. It is a concrete giant standing in the middle of a valley. This unusual configuration was necessary to span the deep Caodu River Valley, but it created a striking visual effect nicknamed the Cosmic Eye. When you look at the bridge from a distance, the combination of the three towering pylons and the gentle sweeping arc of the bridge deck creates a breathtaking optical illusion. The vast open space between the two main spans and the curve of the mountains forms the shape of a giant eye looking up at the sky. It is hauntingly beautiful, but beauty is heavy. The great height makes it vulnerable. The bridge sits in a karst landscape. This means the rock is limestone. It dissolves in water. The ground is full of hidden caves and sinkholes. Building a billion-pound tower on top of Swiss cheese geology is risky. Engineers had to use ground-penetrating radar and extensive drilling to find a solid footing. They also had to design the bridge to resist the wind. When you are 1,000 feet up, the wind isn't just a breeze, it is a force. The Gintang Bridge slashes travel times and fuels economic development. But it also proves that infrastructure can be art. It is a destination. People travel just to see the eye. But what if you need to carry more than just cars? What if you need to carry everything? Asymmetrical engineering. Most bridges do one thing: they carry cars or they carry trains. The Changtai Yangtze River Bridge said, why not do both? And why not add a local road too? This bridge is a beast. It combines three transportation systems in one structure: a high-speed railway rated for 125 miles per hour, a local road for everyday traffic, and a massive expressway for long-distance travel. This three-in-one design transforms what was once an 80-minute journey between Changzhou and Taizhou into a 20-minute trip. It effectively turns two separate cities into neighboring districts. But fitting three systems onto one bridge is an engineering headache. Trains are heavy and they vibrate. Cars are lighter but erratic. Putting them all on the same suspended deck creates a nightmare of physics. The solution is an ingenious and complex asymmetrical design. The bridge features its high-speed railway line on one side of the lower deck. The local road runs right beside it. The upper deck is dedicated entirely to the high-speed expressway. This asymmetrical arrangement with the heavy train on one side required new engineering solutions to balance the load. Imagine carrying a heavy bucket in one hand and a light one in the other while walking on a tightrope. You have to lean, you have to adjust. This side-by-side traffic layout is a world first for a bridge of this scale. This innovative approach earned the Changtai Bridge multiple world records. It holds the title of the world's longest-span cable-stayed bridge for a combined road-rail system. The diamond-shaped towers are a blend of strong steel and resilient concrete. Their unique design provides superior stability against the powerful winds of the river valley. It took roughly 6 years of meticulous work to bring this vision to life. But even this multifunctional giant pales in comparison to the final boss of bridges, the one that looks down on everything else. Don't look down. On September 28, 2025, the Huajiang Grand Canyon Bridge officially opened, and the world gasped. It instantly claimed the title of the world's tallest bridge. Its deck sits 2,050 feet above the Beipan River. Let's visualize that. Stack the Eiffel Tower on top of the Washington Monument. Then add the Statue of Liberty. You are still not high enough. If you were driving across this bridge and you tossed a penny out the window, it would take a long time to hit the water. Clouds often float below the bridge deck. This isn't just a bridge, it is a sky road. It is a ribbon of steel and concrete that seems to float in the void above the staggering beauty of the Huajiang Grand Canyon. Building at this height brings challenges that most engineers never have to consider. The air is thinner, the winds are unpredictable and violent, the temperature swings are extreme. This nearly 1.2-mile steel truss suspension bridge represents the culmination of extreme high-altitude engineering. It is the longest steel truss suspension bridge ever built in a mountainous region. The construction process was a high-wire act. They couldn't use cranes from the ground because the ground was 2,000 feet down. They had to build the bridge from the air. They used a system of cables and pulleys like a giant ski lift to ferry materials out over the canyon. Workers labored on narrow platforms, suspended over the abyss, battling vertigo and the elements. Every bolt, every beam had to be placed with perfect accuracy. There was no room for error. A dropped tool could be lethal to anyone below. A loose connection could spell disaster for the whole structure. It stands as a testament to human ambition, a delicate dance of physics and raw engineering power performed on a grand scale. For the people living in this region, the bridge is a lifeline. It transforms a once hours-long dangerous mountain trek into a simple 2-minute drive. Imagine living in a village where visiting your family on the other side of the canyon took half a day. Now you can see their house from the bridge and be there before your coffee gets cold. But there is a twist. This bridge wasn't just built for locals. It incorporates tourist features. It has glass observation decks. Yes, glass. You can stand on a sheet of transparent material and look down 2,000 feet into the river below. They also added sightseeing elevators. This transforms what was a major geographical barrier into a breathtaking destination. It is a symbol of a country that has stopped trying to conquer nature and has started learning how to coexist with it, even in the most extreme places on Earth. So why the sudden silence from the so-called experts? For years, the critics laughed. They pointed fingers at safety records and called these ambitions impossible. But look at the silence now. It is deafening. Why did the mockery stop? Simple. Because these projects prove that the technological gap isn't just closing, it has been shattered. In fact, in some critical areas of engineering, the gap has completely reversed, leaving the old masters of industry playing catch-up. Think about the legacy of the West. They spent the 20th century building the greatest infrastructure the human race had ever seen. The Hoover Dam tamed the Colorado River. The Golden Gate Bridge defied the Pacific. The interstate highway system connected a continent. They were glorious achievements. But look closer today. Many of those marvels are aging. They are tired. They are crumbling under the weight of time and neglect. Meanwhile, across the ocean, a new generation of impossible marvels is rising from the earth. These massive tunnels and sky-high bridges are not just piles of concrete and steel. They are statements. They are aggressive declarations of power. They say that no mountain range is too jagged to pierce, no ocean trench is too deep to cross, and no river current is too violent to tame. It is a total conquest of geography. It is a warning to every other nation on Earth. If you stop innovating, if you rest on your laurels, you don't just stay still, you get left behind in the dust. The engineers who used to criticize are now scrambling to understand how it was done. They aren't laughing anymore because they are too busy taking notes. The technology developed here is revolutionary. We are seeing composite immersed tunnels that can withstand pressure that would crush a submarine. We are seeing asymmetrical suspension designs that defy gravity. We are seeing curing processes that allow concrete to set in extreme sub-zero temperatures where steel usually snaps like glass. These aren't just one-off tricks, they will set the standards for the next 50 years of global construction. The question isn't whether these structures will hold. That debate is over. They have already proven they can stand. The real question is, what comes next? If they can tunnel through the unstable ocean floor and bridge the clouds themselves, where is the limit? We are witnessing the dawn of a new era, and the map of the world is being redrawn right before our eyes. So after seeing these monsters of engineering, do you think we are witnessing a new golden age of construction? Or is building this fast a recipe for disaster waiting to happen? I want to hear your take in the comments. Don't forget to smash that like button and subscribe for more deep dives.